We have the quotient law, which says if we're dividing the arguments, we are subtracting the individual logs. And we have the power law, which allows us to drop the exponent on the argument down, or if we have a number in front, we can move it up to an exponent. Okay, so we're going to use these three laws to simplify some expressions. I'm not going to do that one. We're going to go right to this one. Use the laws of logarithms to write 1/2 log a 16 minus 1/3 log a 8 as a single logarithm. So the first thing you check is, are the bases the same? Yes, they're both a. Even though it's a variable, who cares? They're the same. Combine these, you need to get rid of the number in front. Okay? You can't combine them if they have a number in front. So we're going to use our power law and move those up, which is going to give us log a 16 to the power of 1/2 minus log a 8 to the power of 1/3. And then, in your mind, what clicks? As soon as you see the power of a fraction, you're talking about some sort of radical, right? Some sort of root. If it's power of 1/2, you're talking about a square root. What's the square root of 16? 4. So this simplifies to log a of 4 minus, if your exponent is 1/3, you're talking about a cube root. What's the cube root of 8? 2. Log a of 2. Now we are subtracting, which means we are dividing. So this becomes log base a of 4/2, which is just log base a of 2. That's it. You're done. Can't do anything else. Can't simplify it anymore. Okay? We're not going to do this part where they say make a 32. So we're going to move the page. Are we okay with that one? If there's numbers in front, flip them up. Shut up, phone. Okay. Simplify. So now there's multiple ways to do these ones. So 3 log x minus log x cubed. You have a choice of moving the 3 up or moving this 3 down. It doesn't matter what you do. So if I move this 3 up, do it both ways. I get log x cubed minus log x cubed. Are those the same? What is anything minus itself? 0. So the answer is 0. If you didn't see that, that's fine, because then what you would do is you would go, okay, log x cubed minus log x cubed. Well, that's the same as log of x cubed over x cubed. Anything divided by itself is what? 1. Log of the number 1 every single time, doesn't matter what the base is 0. So you get the same answer. You could have dropped the 3 down if you wanted, in which case you would have gotten 3 log x minus 3 log x, and you could have recognized that those are the same, and you're going to get 0. They're all the same. I don't care which way you do it. It's whatever way your brain will work that you'll recognize. It does not matter to me. All right. 2 log 5 plus 2 log 2. Couple ways to do this one. What do we want to do first? What do you guys want to do? What do you people want to do? Sorry? Move the 2's up on both of them? So we can go boom, boom, and get log 5 squared plus log 2 squared. We are adding, so that means we are what? Multiplying. What's 5 squared? What's 2 squared? 4. So we're really just going log of 25 times 4. Are we okay with me shorthanding that? Skipping a step there. What's 25 times 4? So now I've got log of 100. Are we done? Why? Why? Yes. Remember, no base written, it's base 10. So it's the same as this. And 100 is 10 squared, which is 2. Okay, but you don't have to show all that. If you know, if you get to this part and you're like, oh yeah, 2. I'm happy. Okay. There's another way to do this one. So you could have, or you may have, said, hey, there's a 2 there and a 2 there, and I like to factor. So you could factor out a 2 and had log 5 plus log 2, which means I'm going to multiply the log 5 and the log, or the 5 and the 2. So it becomes 2 times log 5 times 2, which is 2 times log of 10, which gives you, oh yeah, you could have done that. You can move the 2 up and gotten 100, which would be right there. Or you could just forget the 2 for now. That's a 10. 10. So it's 1. 1 times 2 is 2. There's like 38 different ways to answer these questions. This guy. Log base 3 of 27 cubed over 81 to the 4th. So a couple different ways we want to do this. We could break it up. Since we have things being divided, arguments being divided, we could separate them, right? So we could go log base 3 of 27 cubed minus log base 3 of 81 to the 4th. And then, hopefully in your mind, maybe you go, hey, can 27 be made into base 3? Can 81 be made into base 3? So you could write, well, you could drop the exponents down, but you could go log base 3 of 3 cubed, because that's 27, all to the power of 3, minus log base 3 of 3 to the 4, which is 81, all to the power of 4. You can see why you have to be good with exponents and stuff. So I can multiply these exponents, right? And get 9. So what does this bit become? 9, right? Because it's base 3 of 3 to the power of 9. Minus, what does this bit become? 16. 9 minus 16 is negative 7. Oops. Negative 7. There's another way you could have solved that. You could have, if you wanted, done it right away without separating them. And just said, oh, I can make 27 base 3. That's log 3 cubed that over 3 to the 4, which is 81, which is 3 to the 9 over 3 to the 16. And then if you just look at the inside here, this stuff, that's an exponent being divided, or a same base with exponents being divided. So you're going to subtract the exponents. So you're going to get log base 3 of 3 to the negative 7, which then pops out the answer of negative 7. It's really how you see things. And with more practice, you'll start to see a variety of ways to answer these problems. We're going to do one more and then we're done for the day. And I know this is a lot and I apologize. We're not doing this one. We'll go down here. We're going to combine this into a single logarithm. What's your first step? Any numbers in front need to be kicked up to exponents. So that gets kicked up and that one goes up. Not the negative. The sign in front stays there. So it's still minus log base E5, just a number. Now we just got to put it all together. So anything being added, i.e. positive sign in front of it, is being multiplied, right? And anything being subtracted is being divided. The shortcut is anything being added will be in the numerator, anything being subtracted will be in the denominator. So you can right away just go, well, it's going to be log, add. So b times d times a to the half over subtracted, e to the 5, a squared. Can you simplify this? Does anything sort of simplify? You have a couple a's, right? So if we block out everything else and we just think of our exponent rules, what do I do with these exponents? Subtract them. So you can go off to the side and go 1/2 minus 2. I'm going to do it with fractions. If you're going to subtract fractions, you need a common denominator. So that's the same as 1/2 minus 4 over 2, which is negative 3/2. So this becomes log b d a to the negative 3/2 over e5. If I want the negative 3/2 to be positive, I just drop it to the bottom. And that is your answer. Okay. I'm going to get you to do 1 to 3, 4, A and B, and 7.